Okay, here are three problems that not everybody missed, but most of you guys missed. So let me explain to you where most of you guys went wrong. Let's start with number 12. This one. All right, so it's x times 5 over 6x minus 1 equals negative 1/6. So I took that x as a whole number. I turned it into a fraction by putting it under 1, over 1, I'm sorry. So this line is the same as that line. And I spread them out, right? So the numerator is x times 5, and the denominator is 1 times x times 6. You're fired. So carefully following the rules of fractions, I did this. I took that x and changed it into a fraction of x over 1. And then I just multiplied these out accordingly, right? The numerator is x times 5. The denominator is 1 times 6 times x. And I shifted these in order, right? Because with multiplication, order does not matter. That is called the commutative property of multiplication. But now I put them in different order. So now look, this x is over x. And if I multiply anything times 1, that doesn't change anything, right? So I could just delete that 1. And I did. So now I have x over x times 5, 6. Now x over x is any number divided by itself is 1. With one exception, right? X cannot equal 0. So the domain of x here is any number on the real line except for old Mr. 0. But again, any number divided by itself, x divided by itself is always 1, with that exception of 0. And so 1 times any number is just 5 sixths. Okay? So I have 5 sixths minus 1 equals negative 1/6. I'm going to do my fraction stuff over here. They both have the same denominator of 6. So I mush them together, and I do what it tells me to do on top. So 5 minus 6 is negative 1. So I have literally negative 1/6 equals negative 1/6, which a lot of you guys wrote, but that's not the answer. This is what we call an identity. When something on one side of the equal sign equals the other side of the equal sign, it's called an identity, but that's not the answer. The answer goes back to this times 1 part. Remember, x can be any number except for 0. So that's the right answer. X can be any number except for 0. And by any number, I mean the numbers on the real number line. And this is how we write it with algebraic writing. So x such that x is from the number line except for the little subset that contains the number 0. So that's how you do the first one. Here's the second one. Okay, number 13, this one. So 3 times the parentheses, 4 minus x, close parentheses, equals negative 3x plus 4. You simply multiply out this side, and then you get 12 minus 3x. And I'm changing this minus 3x to plus a negative 3x. Now watch this. I'm going to add a positive 3x to both sides of the equal sign. These guys turn to 0, right? Any number plus its opposite is a 0. And I got 12 plus 0 equals 0 plus 4, and it becomes 12 equals 4, which is not true. Not in this universe. A lot of you guys just wrote 12 equals 4. You know that's not true. So normally we just write undefined. If you get something crazy like this, that means it's undefined. What this really means is this original function up here, this equation up here, 3 parentheses 4 minus x, close parentheses, equals negative 3x plus 4 is false. This is a false statement. Beep, 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 beep. I'm sure nobody's ever taught you that before, but this originally statement is false up here. Okay, let's keep going. The last one is number 14. And there it is. Again, we're going to multiply this side out. So we have 5x plus 20 equals 20 plus 5x. Again, you should see that's an identity right off the bat. They're both the same on either side of the equal signs. But now I'm going to do what most of you guys did. I'm going to add a negative 5x to both sides. So that comes out to 20 plus 0 equals 20 plus 0, which is 20 equals 20. Some of you guys left it like that. Other guys, you did this. You subtracted 20 from both sides, and that gave you 0 equals 0. And again, that is a confounding statement. What that means is that the original x from the original equation up here can be any number from the number line. It can even be 0 here. Okay, there are no restrictions on this one. And this is how we write it up in Algebraese. X can be any number such that, that's what the bar means, such that x can be from the number line, the real number line. So that's it. I hope you enjoyed it, and I hope you learned a lot of stuff. Okay, that's it. MGZ out.